This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be talking about some quantitative stuff related to forces, and for that we'll have to understand three laws of motion, or as you have heard about it, Newton's three laws of motion. Three laws of motion. So, there are three laws of motions, and these are very powerful laws, and they help us being quantitative about the calculations in dynamics, or very simply speaking, how velocities change when a force is applied. Let's see what the first law tells us. Let me tell you, just listen to this very carefully because this will give you a very strong concept on forces. The first law states that every object continues its motion with a constant velocity or continues its state of rest unless a force is applied. This is the first law of motion. This states that every object will continue. It's either, if it's in a state of rest, let's say it has a velocity 0 initially, and if there is no force being applied, it will continue its state till the end of time. Unless there is a force applied, it will stay in its state of rest till the end of times. Or if it's moving at a constant velocity, let's say velocity is 2 meters per second, and every second, if you just find out the velocity is 2 meters per second. It will keep doing so till the end of times, unless there's either there's something to either, if you want to slow it down, you would require a force. If you want to increase the speed, you would require the force. So in either cases, you would require a force to be applied on this object. Otherwise, it will just maintain its constant velocity till the end of times, and this velocity will not change. That is the first law of motion, that every object stays in a state of rest or maintains a constant velocity unless a force is applied to it. So unless the force is applied, an object is in a state of rest or in a state of constant velocity. If you see an object at state of rest or at the state of constant velocity, that means that no force is being applied in either of the cases. No force is applied. Or let's just say no net force is being applied. Force net. What do I mean by net force? Is there might be some forces being applied to this, but we will see that they will get balanced eventually, and there will be no net effect or no total force being applied to this. So if whenever you see, for right now, whenever you see an object at 0 velocity or at a constant velocity, you will always say that the net force is 0. Let's move on to the second law, which is the very basic or very fundamental, let's say, law of physics, which tells us that whenever a force is applied to an object, whenever a force is applied to an object, it will cause, first of all, an acceleration. Whenever a force is applied, it will cause an acceleration, and we will denote acceleration with 2 arrows. So whenever a force is applied, an acceleration will be the result of that force, and that acceleration will be directly proportional to the force. Or simply, or that acceleration will simply be inversely proportional to the mass. Now let's understand this. The first scenario is whenever a force is applied, there will be an acceleration. We saw the cases earlier in the first law, and we remember from the previous videos that whenever the acceleration is zero, there is a case of constant velocity or state of rest. So there are two cases when the acceleration is zero. It's constant velocity and state of rest. But when a force is, and those were the cases when there was no force applied, so there was no acceleration. But then when a force is applied to the object, there is an acceleration, and that acceleration is directly proportional to the force. Let's say if there is a force of 2 newtons, or I will talk about the units as well. If there is a force of 2 newtons and this results in an acceleration of 4 meters per second square. So a force of 4 newton will result in an acceleration of, the relationship says they are directly proportional, which means that the force, it's doubling, or it's 2 times the original amount. So the acceleration will be 2 times the original amount, which would be 8 meters per second square. If you take it to 8 newtons, so this is 2 times this force. So the acceleration of this mass, if this mass is kept constant, so the acceleration of this mass would be 2 times the acceleration earlier. This would be 16 meters per second square. So that is what it means. Whenever the force applied is directly proportional to the acceleration of the mass. And if let's say keep the force constant, we obviously, whenever we are solving these type of questions, we have to keep one constant. So let's keep the force constant now. The force is fixed. Let's say the force is 2 newtons in all the cases, 3 cases, and we are talking about this rule where it says acceleration is inversely proportional to the mass. So if now we are changing the mass and the acceleration, let's see, if we have 1 kilograms, let's say the acceleration is 2 meters per second square. But let's say we are increasing the mass. Let's say now the mass is 2 kilograms and the force is fixed, is 2 newton. Since the mass has increased twice, you can see there is an increase of times 2. The acceleration will decrease by times 2 because this is inversely proportional. So it will exactly decrease by times 2. So this should become 1 meters per second square. If this is, let's say, 4 kilograms, the force is fixed. So the acceleration, since the mass has increased 2 times, the acceleration will decrease by twice, which means this would become 0.5 meters per second square, half of the one earlier. So this intuition is very important for you guys. So based on this, we have a formula on the second law of motion, which says, since we know acceleration is directly proportional to force and acceleration is inversely proportional to the mass, this gives us the formula F is equals to m times a, which means force is equals to mass times acceleration. In this formula, you can see if you keep the mass constant, an increase in acceleration would mean an equal increase in the force. However, if you keep the force constant, let's just switch the formula, this will suddenly become this way. This is the constant. And an increase in mass would mean a decrease of the same magnitude in acceleration. So this is a very important formula, and we will be using that in many applications across physics. So this is the definition of force. Force is equals to mass times acceleration. And what does this mean? That, for example, for a mass of let's say 1 kilograms, if I apply a force of 2 newtons, there will be, let's just find out the acceleration. We have the formula, we know the force and the mass. So force divided by mass, 2 divided by 1 will give us acceleration, which would be 2 meters per second square. So an object would move a distance of 1 meters, an acceleration with an acceleration of 2 meters per second square. So this is what the scenario is. This is what it gives me. That if I know the force and the mass the force is being applied to, I can find out the acceleration very easily using the same formula. So let's talk about the units of this using this theory. We are still talking about Newton's second law, and we have figured out F is equals to ma. If we need to figure out the units of force, we can simply use the same formula as we have seen in the earlier videos. In the units section, we just replace m with its units, which is kilograms, and the units of acceleration, which is meters per second square. So the units of force is simply kilograms times meter per second square, and this entire thing is known as newtons. So if you have this, you can simply replace it with a newton. So basically, if I say what is 1 newton, if I ask you what do you mean by a force of 1 newton, what you do is simply just get an intuition of this formula and try to understand. If I need an answer of 1 newton, the simplest way would be to multiply 1 times 1. So if I multiply 1 times 1, I will get an answer of 1. So what does a force of 1 newton tell me? This tells me that a force of 1 newton is exerted on an object of mass 1 kilograms, you can see, and moving with an acceleration of 1 meters per second square. So if an object of mass 1 kilograms is moving with an acceleration of 1 meters per second square, we say that is 1 newton, and that is the definition of 1 newton, or simply a newton. So an object, it is the force an object experiences when it has a mass of 1 kilograms and it's moving with an acceleration of 1 meters per second square. So that is very basic law of physics that we'll be using, and we'll be seeing this in the next examples that we'll be doing.